Oh, hi, this is Luke from the Stats Medic. And in this video, we're going to talk about type 1 and type 2 errors. And we're going to do that using the activity titled, Should Rockford Switch to Bottled Water? So we only have one learning target for this lesson, and that is to interpret a type 1 and a type 2 error in context, and then to be able to give a consequence of each error in a given setting. So let's take a look at the activity. So it says here, the Wolverine Worldwide, a shoe company in Rockford, improperly disposed of chemicals, PFAS, which have leaked into the groundwater. The state of Michigan says that if more than 7% of households in a city exceed the safe limit, the city needs to switch to bottled water. A concerned citizen takes a random sample of 100 households and finds that 12 have unsafe water. Do the data provide convincing evidence that Rockford should switch to bottled water? So you have everything that you need in order to complete the activity through question 4 here. So go ahead and work through that on your own and then come back here to check your answers. So you can pause the video now. Let's check in and see how you did on the activity. For question 1, we had to write out our hypotheses here. And so hopefully you decided that the null hypothesis was that P is equal to 0.07. In that case, the water in Rockford is safe. So let's just add in a little note here that the null hypothesis is actually saying that the water is safe. And the alternative is that that proportion of households that is have unsafe water is greater than 7%. That would be that the water is unsafe. Now make sure when you're defining your parameter P here that you're referring to the population, and I've done that by using the word true and then also referring to all households in Rockford with unsafe water. Okay, for number 2, we get a p-value of 0.025, and at this point we're getting pretty good at interpreting the p-value, I hope. So the first part is always to say that we are assuming the null hypothesis is true. In this case, that the water is safe and that the proportion is 7%. There is here's your p-value, 0.025 probability of getting a p-hat value of 0.12 or greater purely by chance. And that p-hat value was that 12 out of the 100 based on the sample from the concerned citizen. Now that interpretation of the p-value is going to help us with 2b here. Do we reject the null or fail to reject the null? Well, because that p-value is less than our significance level alpha, we are going to reject the null hypothesis. And if we reject the null hypothesis in favor of the alternative, we think now that the water is unsafe. And our suggestion is that Rockford should switch to bottled water based on that very low p-value that we have there. So part C says, let's suppose that this decision is wrong. What would be a consequence? So maybe Rockford buys all these bottled waters, but in reality, they didn't have to because their water was actually safe. Well, the consequence there is that it is going to cost Rockford a bunch of money in order to buy all that bottled water when they didn't really have to buy it because the water was safe. Now, this particular error is what's known as a type 1 error. And for a type 1 error, you're always going to have the null hypothesis being true. So in this case, the null hypothesis is that the water is safe, but your decision is a wrong decision. You've made a mistake. And so the mistake here we made when we decided to reject the null hypothesis. So for a type 1 error, you're always going to have the null true, and you're going to incorrectly reject the null hypothesis. Okay, that's what makes it a type 1 error. The null is true, but we incorrectly reject the null hypothesis. Now for part D, it says, if the water is safe, what's the probability that this error will occur? Well, if the water is safe means that the null hypothesis is true. And if the null hypothesis is true, we will incorrectly reject the null whenever our p-value is less than 5%. And of course, that's going to happen 5% of the time. In fact, the probability of a type 1 error is always going to be equal to whatever our alpha level is. Like for this problem, our alpha level is 5%. So in general, the probability of a type 1 error for a significance test is just equal to alpha, the significance level. Okay, let's move to question number 3, where we have a new p-value now, much larger p-value of 0.217. And so based on that one, we have to make a decision. Well, this one is definitely greater than our alpha level. And so our decision here is going to be to fail to reject the null hypothesis. And in this case, we're going to tell Rockford that they should keep the current water. Okay, they don't have to switch to the bottled water. We don't have convincing evidence that the water is unsafe. So go ahead and continue to use the current water. Now, part B says, let's suppose this decision is wrong. What would be a consequence of this error? Well, we've just decided to keep the current water, but what if the water is actually unsafe and that was a mistake? Well, in this case, many people in Rockford are going to be drinking unsafe water. And this could be bad because people could get sick or they could die. So this particular error is called a type 2 error. And what makes this one a type 2 error is that here we have unsafe water. Remember, unsafe water is the alternative hypothesis. So for a type 2 error, you're always going to have the alternative hypothesis being true. And then you make the bad decision. In this case, the bad decision is right here when we decided to fail to reject the null. So that is what makes it a type 2 error, is that the alternative is true, but we fail to reject the null hypothesis. And now the final question here is to ask if the consequences in question 2 or 3 are more serious. Well, remember in question 2, Rockford was spending a bunch of money on bottled water when they didn't really have to. And the consequences in number 3 was that they kept to the current water and people continued to drink it even though that water was unsafe. And I think very clearly here, the consequences in number 3 are much, much more serious, because we certainly don't want people drinking unsafe water that could lead to health problems there. So we definitely think in this case that the type 2 error has much more serious consequences than the type 1 error. So let's go ahead and summarize what we learned in the activity in the important ideas. For the important ideas, let's go back to the learning target from the beginning of the lesson, and there was only one, and that's to be able to interpret type 1 and type 2 in context and to give a consequence. And so we're going to do a couple of things in the important ideas here. The first of which is we're going to create a table, and you're going to see where the type 1 error and type 2 error fits within this table. And it's just a 2x2 table here. So you're going to set up a rectangle with 4 different locations in it that looks something like this. And here's how we're going to organize this. On the top, we're going to have the actual truth. And there are only 2 possibilities when you're doing a significance test. Either the null hypothesis is true or the alternative hypothesis is true. Well, then we do a significance test, and at the end of the significance test, we have to make a conclusion. And there are 2 different conclusions that we could make. The first conclusion that we could make is that we could reject the null hypothesis. So let's put that one first here. This would be reject H null. And the other conclusion that we can make, of course, is to fail to reject H null. So that'll go here. And we end up with 4 different cases. And let's consider each one of those cases individually and try and decide if we have an error or if we have a good decision there. So if we start in the top left here, that is where the null hypothesis is actually true, and we've rejected the null hypothesis. An obvious error here. In fact, we know that this is what's called a type 1 error. So the type 1 error is in the top left of this diagram. If we move to the top right, that's where the alternative hypothesis is true, and we reject the null. Well, that would be a good decision here, right? We would feel good about that. So for this one, I'm just going to put smiley face, which means yes, we made the correct decision there. Okay, if we move to the bottom left, for this one, the null hypothesis is true, and we fail to reject the null hypothesis. Well, this is also a good decision. So I'm going to go ahead and label this one with a smiley face as well. And then we've got one more in the bottom right here. This is where the alternative is true, and we fail to reject the null hypothesis, which would be a mistake, right? That would be an error. In fact, this is your type 2 error. So hopefully this table keeps your thoughts organized and helps you to remember type 1 error versus a type 2 error. So let's try and summarize a little bit and talk about how we should interpret these errors here. So let's start with the type 1 error. And what we can see very clearly in the diagram here is that for a type 1 error, the null hypothesis is true. And we've made a bad decision, we've made a mistake, which means that here we reject the null hypothesis. So let's talk about how you would interpret type 1 error. All right, so I'm going to put quotes around this because this is the interpretation. So you're going to start by saying what the actual truth is, and then talk about the decision, the incorrect decision that was made. So the truth here is to say the null hypothesis is true. So you would say this in context, right? The null hypothesis is true, but in the context of the problem. But we have made an error here. And the error is that we reject the null, which means that we find convincing evidence for the alternative. So we're going to say, but we find convincing evidence for HA. And of course, this is where we could insert the context of that particular scenario there. So that's how you would interpret a type 1 error. For a type 2 error, well, first, we know from the table, but we also know from the activity that a type 2 error means that the alternative hypothesis is true. And the error or mistake that we've made here is that we fail to reject the null. So let's talk about how we would interpret this one here. All right, so we would say the alternative hypothesis is true. And this is where we would put in whatever the context is for the alternative hypothesis. But we have made a mistake here and we failed to reject the null hypothesis, which means we did not find convincing evidence for the alternative. So, but we did not find convincing evidence for HA. And of course, this is where we could put the context in as well. So that gives you a little bit of a template that you can use in order to interpret type 1 error and type 2 error. Now, the one other important idea that we did get here is that for the type 1 error, we did discover that the probability of making a type 1 error, of rejecting the null when the null is true, is actually just our significance level alpha. So let's see if you can apply your learning in the check your understanding problem here. So go ahead and try the check your understanding problem on your own, and then come back here to check your your answers. So you can pause the video now. Let's see how you did on the check your understanding problem. Now, before we look at the questions, I do think that it's helpful when you're trying to identify type 1 and type 2 errors that you have a very clear understanding of the null hypothesis and the alternative hypothesis in the context of the problem. So in this problem, the null hypothesis saying that P equals 0.75, that means the coin that Mr. Wilcox has purchased is working exactly as it should, right? The company claimed that 75% of the time it lands heads. So the null hypothesis is really saying that the coin works as advertised. And I think this is going to be helpful to have it written out in words here when we go to interpret the type 1 and type 2 error. Now, of course, the alternative here is that the student collects some data and thinks that the coin is not performing like it should, that it's actually less than 75% of the time we're getting heads. And so the alternative here is that the coin is not working as advertised. So let's look at question number 1 to describe a type 1 error and a type 2 error. Well, remember, for a type 1 error, the null hypothesis is true, and we've made a mistake and we've rejected the null hypothesis. So we start by giving the truth, and the truth is that the null is true, or the coin works as advertised. But we've made a mistake here. We've rejected the null, which means that we did find convincing evidence for the alternative. So we find convincing evidence that the coin is not working here. For the type 2 error, remember, this is when the alternative is true. And the mistake or the error here is to fail to reject the null. And so we start with the truth, and the truth is that the alternative is true. So the coin does not work as advertised. That's our alternative hypothesis. But we made a mistake here and we failed to reject the null, which means that we do not find convincing evidence for the alternative. Now, question number 2 says, which type of error may result in Mr. Wilcox returning the coin and writing a negative review of the product? Well, that would be if Mr. Wilcox thought that the coin was not working properly, which you can see up here is what we said in the type 1 error, right? That we find convincing evidence that the coin is not working, in which case Mr. Wilcox might return that coin back to the company, write a bad review, but actually he shouldn't have, because the coin was working as it should be, but we just found convincing evidence that it wasn't working. So maybe a little bit embarrassing for Mr. Wilcox. And so maybe the student decides to change the alpha level, right? In the hopes of avoiding Mr. Wilcox being embarrassed by returning the coin and writing a negative review. Because if the student changes the alpha from 0.10 to 0.05, we know that this is going to reduce the probability of a type 1 error. And so this error that Mr. Wilcox is making is less likely to happen if we were to reduce the alpha level there. So this concludes the video for type 1 and type 2 errors. Thanks for watching.